Good day. We are looking at producing some predicting products notes. So find your predicting products practice sheet and do not hand this in. You should also have your periodic table, your table of complex ions, and the sheet you got earlier called Predicting Products Rules of Thumb. So hopefully you have those things, those are your tools in your toolkit. Now, when we do these questions, first of all, I guess we have to give ourselves a name here. So let's call ourselves Key. And normally you'd attack questions, go for 1, 2, 3 on down until 10. But not when you're predicting products. We want to do the easier ones for predicting products and save the tougher ones for later. So the easiest ones to start off with are combustion. That means we're looking to obviously the left of the arrow. And we're looking for O2s all by themselves. So there are two combustions. This is the burning of a hydrocarbon. This is the burning of a metal. In this case, we have to remember when we burn a hydrocarbon, and if we burn something organic, we always make CO2 and H2O. And if you ever did a test on this and forgot, a lot of times you can find that in other questions. Like if I just asked you to balance an equation, you would see this stuff to the left and you'd see CO2 and H2O. Then we have to balance, so we got to balance out our carbons. And that's a 6. We have to balance out our hydrogen, 6 here, so we need a 3 on the right. And then we go 6 times 2 is 12. 12 plus 3 is 15, so we have 15 oxygens there. So a number multiplied by 2 that equals 15 is half of 15, and we put in 7.5. That would get me my 3 marks. 1 for classifying, 1 for writing proper formulas in the right, 1 for balancing. This one is even easier. Number 8, all they're going to do is get together. Cadmium, when you look it up, is 2 plus. Oxide is 2 minus, so we need 1 of each. CDO. And then we balance with a 2 here and a 2 there. And that's it. All good. Now some of you are saying, oh, I could just put 0.5 right here, and that's correct as well. On your rules of thumb, it says after combustion, we go for decomposition. We go for decomposition because we're looking for something with no plus sign. Plus sign here, no plus sign there. That's decomposition. And we come down plus, 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 plus. Oh, no plus sign. So there are 2 decompositions. This one is a special case that we must memorize. It doesn't split into a positive sodium ion and a chloride ion. In fact, it splits here. And so this is a nice way of storing oxygen. And when we heat it up gently, we get sodium chloride and oxygen. So now I got 2 marks. Got to balance it, so I can put a 1.5 there. Or more commonly, we go 2, 2, and 3. And if you forget that oxygen's diatomic, I cannot help you. You were told to memorize that. Plus, when you look here, oxygen's diatomic. And oxygen's diatomic. So you got stuff just hanging out in front of you. Next decomposition, this one will split into magnesium and chlorine gas. You got to be careful with this one. You will poison yourself if you're not. Now somebody's saying, hey, these things are the same. No, they're not. Here, this is made of ions. They bonded together. They're going to have different properties than when they're separate. This will be solid magnesium, the kind of thing you might have seen in a ribbon, and I've handed to you in previous labs. And chlorine is our poisonous gas. It happened to come out balanced. That was just luck. It happens that this is monatomic and this is diatomic. Often these things, when they split up, they will not come out in a tidy fashion. Now, next one we're looking for is synthesis, and that means we're looking for a couple of elements coming together. And that means you better know here is compound and compound. Oh, here's element plus element. So that's a synthesis. Now, let's see, do we have any other synthesis down here? This actually is synthesis as well, but we'll get to that later. Now, when we look at the formula we get Fe2S3. Now, somebody's saying, hey, I could write down FeS. It doesn't say if the iron's 2 plus or 3 plus, and you're right. So either would be acceptable. I've gone for the more complicated one, and I said Fe2S3, and now I have a 3 here and an 8 there, so I just do a switcheroo. put the 3, put the 8. 8 times 3 is 24, 3 times 8 is 24, and then I go 8 times 2 is 16, and I balance out the irons. That is now all balanced. Would have been a little easier if I'd gone for FES. The other synthesis, as we said, was this one here, and if we were giving you a test, that's where you get 4 marks out of 3. You get 2 marks for classifying, 1 for predicting products, 1 for balancing. But you're missing out on the fun of a chemical reactions test. It's just tragic. Okay, well, we are left now to go after single replacement. That means we're looking for an element and a compound, or a compound and an element to the left of the arrow. This is not. This is element, compound, element, compound. 2 compounds, 2 compounds. So these are single replacements. We have to remember, here we have a nonmetal. Nonmetals kick out nonmetals. This nonmetal will develop a negative charge that wants to stick to the calcium's positive charge. We could use the activity series to see what happened, and it actually would not happen, but it's just a crazy example. We have to write proper formulas for chlorine that's been booted out and calcium bromide. So there they are. Now if I wrote calcium bromide plus Cl2, that's equally correct. This one happens to come out balanced. So got lucky. But I wrote proper formulas. I remembered chlorine as a halogen diatomic. Zinc is going to kick out nickel because metals kick out metals. And on the activity series you would see that this one does occur. And so we're going to make zinc nitrate and we're going to make pure nickel. That one happens to come out balanced as well, but that is something you would have to check. What's left? All these have to be forms of double replacement. But of course I have to give you an example of neutralization. So here's a compound, double replacement. Here's a compound, double replacement. Why are they double replacement? Because we don't have an acid and a base. We have a salt and a salt and a salt and a salt. If you had an acid and a salt, that would be double replacement. You have to have an acid like this and a base like this to be to be neutralization. So let's take care of double replacements. Boom and boom. What happened there? Well, let's fix that. So we've made that double replacement, and that's double replacement. Now this is the double date gone sour. The zinc arrived at the dance with sulfate. Strontium arrived with chlorine. They both scrap, so this couple breaks up, this couple breaks up. Zinc gets together with chloride, strontium gets together with sulfate. And we always put the positive ion first. So there are formulas. The metal ahead of the nonmetal, the metal ahead of the complex ion. Is it balanced? Well, we take a look. 1 zinc, 1 zinc, 1 sulfate, 1 sulfate, 1 strontium, 1 strontium, and 2 chlorines, 2 chlorines. So that one is done. This one, this is another double date gone sour. This couple is going to break up. This couple is going to break up. Aluminum gets together with carbonate. Sodium gets together with chloride. Every year I get people to write down Na2Cl3. That is brain damage, no offense. Because sodium's 1 plus, chloride's 1 minus, you should know it's NaCl. So there are our formulas. We did some crisscrossing. Aluminum's 3 plus, the 3 came down there. Carbonate 2 minus, the 2 came down there. This one clearly is not balanced. So we see 2 aluminums, we're going to need 2 there. We see 3 carbons, we're going to need a 3 in front here. So there's our 2, there's our 3. Now 2 times 3 is 6, so we have 6 chlorines, so that's one reason to put a 6. 3 times 2 also is 6, so a 6 is going to finish us off, and it is balanced perfectly. So right now I've got 28 marks out of 30 because I picked up that 1 bonus mark. But I want to get 31 out of 30 in this game. And so I look at this, I said acid plus base, so that's going to be neutralization. And there we write neutralization. Now acid plus base makes salt plus water. Our salt is going to be the strontium getting together with the nitrate. Front end of this compound getting together with the back. The H and the OH are going to get together to make the wah-wah. So let's put in our products. Proper formula. Strontium's 2 plus, nitrate's 1 minus, the 2 and the 1 crisscross. Having done that, we have to say, is it balanced? And we can look at our hydrogens to see that we got a problem. We got 3 hydrogens there and 1 there, and we got 2 hydrogens there. Now you might say put 1.5 there, but that's really going to gibble things up. An easier way to tell is every time I have an H and an OH get together, they make 1 water. So if I have 2 hydroxides, I want to have 2 hydrogens. Now, if I have 2 H's and 2 OH's, that's going to make 2 WOAs. And that one should now be balanced. Well, let's check it out. 1 strontium, 1 strontium. 2 nitrogens, 2 nitrogens. Then we have 2, and 2 is 4 hydrogens. 2 times 2 is 4 hydrogens. I have 6 oxygens here, plus 2 makes 8. 6 oxygens here, plus 2 makes 8. And whenever you think you've got something balanced, you should check element by element to make it make sense. Now you have a balancing or predicting products practice number 2. I think that's the title of the worksheet. And incredibly, when you go to classify it, you're going to find it goes in the same order. And you say, gee, that's making it easy. Well, this is moderately challenging. And the reason I've done that is it'll hopefully help you start to see the patterns for how these things combine. The later predicting products worksheets will not be so friendly. You'll have to do more thinking. But these are early days, and we want you to get off to a solid start. I do expect to receive questions about this work, but look at what you have to know. You have to know how to write formulas. You have to know how to write ionic formulas and occasionally covalent formulas. You have to memorize that when we burn a hydrocarbon, it makes CO2 and water. You have to know how to classify reactions, and that's from earlier in the week. And you have to know how to count atoms and balance equations. So if you can do this kind of worksheet without much problem, it means you've been paying attention in the chemistry unit. You'll get more worksheets on it, and then we're going to do a lab with 8 reactions. And guess what? You're going to have to classify, you're going to have to predict products, and make observations. Hopefully it goes well.